In this problem, we need to write a piecewise defined function to describe this graph. I can see there are going to be three pieces here. A piece on the left, I'll write that one down first, a piece here in the middle of the domain, and a piece on the right. The piece on the left goes forever to the left. The piece on the right goes forever to the right. The piece in the middle is a segment. It's got a starting point and a stopping point. So when I write the function, I'm going to need three pieces. I'm going to start with this ray on the left. It can be written in slope-intercept form because it is linear. So we can write it as f of x equals mx plus b. Our m is going to be the slope. For every 2 units we rise, we can run 1 and still be on that graph. So our slope is 2 for the first piece. So we have y equals mx is 2x for this particular graph. And the b value is the height at which it crosses the y-axis. In this case, it's a -1, so I have -1 as my b term. I'm not going to worry about the domain column yet. I'll come back and get all those in the end. For this piece, it's a flat line, meaning it has a slope of 0. So I could call it y equals 0x plus b, but writing 0x doesn't really accomplish anything. I'm just going to write down the b value for this. If you extended this over, it would cross the y-axis at a height of 3. So we have f of x equals 3 for the equation of that segment. And for the piece, the ray on the right, it goes forever to the right. It is also linear. It can be written in slope-intercept form. The slope is 1. Because if you go up 1 and run 1, you're back on the graph. Up 1, run 1, you're back on the graph. So I could put a 1x here. I'm just going to call that x. Now the b value is a little trickier. I would have to continue this pattern back to the y-axis to see where it would cross if it were in fact going to cross the y-axis. It would cross at a height of 0 at the origin, so I'm not going to write that plus 0 term. I'm just going to leave it as y equals x. The domain for each of these are the x values where the pieces exist on the graph. This first line goes forever to the left, so it starts out at -infinity and continues until you get to, let's see, right there, continues till you get to an x value of 3. So we can say this first piece is true whenever x is less than, just less than 3, because its endpoint is not included, so I cannot include the 3 in my inequality. This middle piece starts where the old one leaves off. So it starts at 3, and it ends very quickly at 4. So 3 on the left, 4 on the right. X somewhere in the middle. Both endpoints are included, so I'm going to use less than equal to signs for both pieces of that inequality. And finally, the domain for the yellow graph here. The yellow graph actually started here at 4 and continued forever to the right. So that's going to be all x values that are greater than 4. Since my endpoint is not included, I cannot use an included inequality sign. And this would be the piecewise defined function for the graph.